Hello everyone, welcome to my YouTube channel. Today I'm solving Leetcode question 146, LRU cache. Design a data structure that follows the constraints of a list recently used LRU cache. Implement the LRU cache class. LRU cache with the integer capacity. Initialize the LRU cache with positive size capacity. And then to get the key, return the value of the key if the key exists, otherwise return -1. And then you can put the key and the value into the cache. It means update the value of the key if this key already exists in the cache. Otherwise, add the key value pair into the cache. If the number of keys exceeds the capacity from this operation, just remove the list recently used key. The requirement for get and put function is O1 average complexity. Let's take a look at this example. So we first initialize LRU cache. So we perform this initialization with the capacity 2, and then we put and then the input parameter for calling put is 1 and 1. So now the cache has key 1 and value 1 in it. And then the next operation is also put. Now the cache contains two elements, one key 1 with value 1 and key 2 with value 2. And then we get the value for key 1. In this case, we just return the corresponding value. It is 1. And then we put key 3, value 3 into this cache. So in this case, we need to remove the least recent element from this cache because the cache capacity is just 2. So in that case, we evict the value 2 with key 2. So in that case, the cache only contains key 1, value 1, key 3, value 3. And then we call the get function to get. But before this get function, do you know why in the previous step the least recent used key was 2? It is because before that we already called get function to get the value of key 1. So in that case, even though this key 1 was inserted the first into this cache, but it's recently used because of this get operation. So that's why the key 2 becomes the least used when we call put 3. So now move on. So we call the get function to get the value for key 2, because in this case the key 2 no longer exists in the cache since we just evicted it from the cache. We return -1 to indicate we have not found the value for this key. And then next we put the key 4, value 4. In this case, it exceeds the capacity because the cache already has 2 elements in it. So we remove the least recently used, that is the key 1. Now the cache is 4, 4, and 3, 3. So in this case, when we call get 1, key 1 does not exist anymore, so return -1. We call get 3, we get the corresponding value 3. We call get 4, we get the corresponding value of for key 4, which is also 4. So that's why this is the output. So the input are the two lists. One list is the corresponding operation. So LRU cache means initialize that LRU cache and then put element into it, and then get the element or the value for the corresponding key. So that's kind of the second list is the input parameter. When you initialize your cache, your capacity is 2. When you put key 1, value 1. When you get the value for corresponding key equals 1. So that's the problem statement. So now let's try to think about how to solve this one. So I already put in the comments that this one should be solved using dictionary and double linked list. Now I'm going to show you how to figure this out. So let's try to think through this problem. First, what we need to keep track of. So along the process, we need to keep track of the capacity of the LRU cache, since we need to check if we have exceed the capacity every time we are trying to put a new element. And then it mentioned the function get and put must each run in O1 average time. So when we're trying to return the value of key, so we should think about dictionary. So dictionary has the corresponding key and value pair, and then in that case, if we want to retrieve a value from the dictionary based on the key, we can get that in O1 average. So now we figure out, okay, we probably need a dictionary data structure. And now next we think what operations we need. So this problem statement is quite long, so that's why I list out the different operations and then try to help me sort out the logic. So first we need a get operation. So in this case, we break down into two scenarios. We check if this key exists. If it exists, we just fetch the value of the corresponding key. After fetch that, we need to make sure this key value pair becomes the most recently used. So don't forget this one. If the key does not exist, that's simple, we just return -1. And then for the put operation, we also check if the key exists or not. If the key exists, we just update the value of the key. And after that, we make sure that this key value pair becomes the most recently used. If the key not exist, we just insert the value of the key. After that, we also need to make sure that they are the most recently used. So after the update or insert value of the key, we can check if it exceeds the capacity. If it is, we just remove the least recently used element from this dictionary. So we just like insert into the dictionary and delete it from the dictionary. So we can also do things in a reverse order. So before so the reason why I do this eviction after that is instead of before doing that, it's just like easier. Let's say because before we may or may not need to insert one additional element based on the condition that if this key exists or not. If this key exists, we just simply need to update the value of the key. So that's why I make the capacity check after I perform this operation. So the order for doing this eviction doesn't really matter. We just need to make sure, okay, after this put operation, we either updated or inserted the corresponding key and value, and then we maintain a cache of the not exceed the capacity. So the next question I ask myself is how to make this key value pair most recently used. So if the key exists, already exist in this cache, we just need to remove key value from the original position. If it's not exist, and if it not exist, we just don't need to worry about the remove from the original position. But in both cases, we need to insert this key value in the latest position to denote, okay, those are most recently used. So that's kind of the process of making this key value pair most recently used. So in that case, so now we have an idea. We may need to keep track of the position. So how to keep track of the position? We will come back to that later. So we know that, okay, so now I ask the question, what data structure to use? So I already know that I need to use a dictionary. So it has a key. This is just the same as the key from problem statement. And what is the value? So that goes back to the original question, how are we going to keep track of the position? What is the most recently used? What is the least recently used? So in this case, I'm just going to use a node, basically a double linked list. So I have a node of key and value. So this node keeps track of the corresponding key and the value. This node also pointed to the previous node and the next node. So in that case, I kind of keep the order of all the elements in this cache. So in that case, you may ask how to keep track of the list recently used. So basically similar to the idea of like in binary tree, you have a root node or two, and then you start with the root node, point to the children of that root node. Here for a linked list, we can have a start node. So basically we can create an empty node to point to the list recently used element. Basically how to do that, just to make sure this empty node's next node is the least recently used element. So in that case, we use the node empty node. By empty node, I mean node with empty key, with zero key and zero value. So that's basically node 0, 0. So this denote the start of this linked list and also the start of the cache. And then this points to the list recently used element. So basically just by assign that element to this node's next. And then how to remove a key value from the original position or insert into the new position. That's some operation we need to perform. So in that case, for insert or deleting nodes, we can use the node next or nodes previous. So if you remove a node from this linked list, so you just make sure that for the previous node of this remove node and for the next node of this remove node, now their previous and next are pointing to the right node after the removal. We also need to keep track of the the most recently used. So basically, that's we because we need to, after we make the put operation, or we need after we get the operation, basically after we use a key value, basically after we use the corresponding key. So in that case, we need to make the key value most recently used. In that case, we use a node, also a node 0, 0. In this case, this node's previous nodes point to the most recent use. So that's the overall idea. So I think the hardest part for this one is to correctly understand the problem statement. So don't forget that after the get operation, you also need to make sure the key value are the most recently used. And then you need to think about how to keep track of the least recently used, most recently used. So it's not super hard to figure out a dictionary. We need a dictionary data structure because it's get and put run in O1 average time complexity. So it's pretty intuitive, but not so intuitive to figure out the this node in the double linked list. So you may ask, so why not to also use, instead of using a node in the double, and then to construct a double linked list, why don't we just to use something or some other data structure just to denote the order? Let's say if the node is inserted most recently, then we just like assign an order. Basically, we assign value 1 to indicate that that node is insert that key value pair is inserted the first, and then why don't we just use that to keep track of it? I thought about it, and then it's just like it got super messy. So let's say, how do you keep track? Okay, after you insert new node, update with the most recent position, and then after you delete or remove the least recent used, it's just like super hard to keep track of all the changes in those like so-called order. So I think in this case, the double linked list and then use the node, previous node and next node. So it's actually the most easiest and it's the easiest way to do this. So we talk about the idea of solving this problem. Now let's start coding it. So we know that we need a node. So we construct a node class, and then we define the how the so for this node we need a key and value. So in that case, we just assign self dot key equals key, self dot value equals value. We need key value because we need to keep track of the key value, and we also need the previous node, point to the previous node and point to the next node. But we do not need to determine the previous node and then the next node during the initialization. So we can just initialize with the key and the value, and we can determine the previous and the next node later. So in that case, I'm just going to initialize them to none. So basically, I create a node. So for this node, I keep track of the key and the value. So those are the input when I initialize this node. And then initially, I assign the previous node and next node to none. So basically, I just have this single node, and I haven't put into the linked list yet. So I do not know what is the previous or next node at this time. So we do not need to worry about that when we initialize this node. We can update this information later as we insert it into a linked list or put it into a linked list. So now for this LRU cache, we discuss what we need to keep track of. We need to keep track of the capacity. So in that case, it just equals the capacity. And then during the initialization, we usually want to, initialize, also create the data structure we want to use. So we have already taken care of the data structure, the node in the double linked list. So we want to create the dictionary during the initialization. So self the dot cache equals, so that's start with an empty dictionary. So that's actually our cache. And then we mentioned that we need to probably track the start and then the end of this double linked list. So basically we need to track of the least recently used element in the cache and also the most recently used element in the cache. So in that case, I have two node. So self.start equals start equals the empty node. So this point to least recently used. So this one is point to most recently used. You can also think them as the start and then the end of this cache. Since we already inherently create this order, we use the node in this double linked list. So we track the previous node and next node. So inherently we create the order. So you can think about this start and the end. They are just empty nodes. So start will point to the least recently used element in cache, and will point to the most recently used element in the cache. So they kind of denote the start and the end in this cache. So that's what we need to initialize. So now let's think about how to get the element. So we check if this key is in the dictionary or not. If key in self.cache. So in this case, we need to update the value. We need to return the value. So we are writing the get function. So in that case, we just return so basically we need to return the value. That can be done by return self.cache key. But before that, we need to also update this key to most recently used. So how to update this one to most recently used? So we need to remove from original position. And then we need to insert into the most recent position. And then, so those are the two options we need. And then it seems that we also need to use those two methods. We are trying to write a code for put function. So in that case, we may want to try to create two function or method for remove and insert. So basically, if we have a remove, we are trying to remove a node. And then we are trying to insert. So those are the functions. So in that case, we can just call self.remove to remove this node. So remember, for this cache, in this cache, the key is just a key. So it has key, and then for each value is a node. So node of the key value. So that's kind of what's in this cache. So in that case, we are trying to remove the node. We just remove the corresponding node. So how are we going to get this node? So we call cache key. And then insert into the most recent position. So in that case, we need to first create a node. So node with the key, and then cache. And we need to get the value for this one. So in that case, what we need to get is, we first need to get a node before we actually remove that. So node equals self.cache.key. And then we can just perform remove this node. And then after remove this node, we need to insert this node into the new position. And then after the update, we just return the value. And then else, if key is not in this self.cache, in that case, okay, we need to return the value. So that's self.cache.key.value. So self.cache key get us a node, and then we access the value by calling node.value. That's here. Else that's simple, we just return -1. So now we need to code this remove and insert function. So to remove a node, so basically remove a node is like to make sure the previous and the next pointer points to the correct node after the removal of the current node. So we need to keep track of the previous and next equals self.node dot previous, and then self.node dot next. So now we are getting the previous node and then the next node. And then we need to remove this node. So in that case, so previous dot next So right now, before the removal, this previous node's next node is my node, this target node. So now I need to point to this target node's next node. So that equals the next. And then before the removal, this next previous is this node for removal. So in that case, after remove this node, it has to point to the previous node of this node. That is equals previous. So that's kind of how we perform the remove. So to perform remove, to remove a node from this double linked list, so we need to first get the previous node of this node, and then also the next node of this next node, and then we need to make sure that the previous node of this node will point to this node's next node after removal, because after removal, this node will not exist. So that's what's done by this line. And then we also need to make sure this node to be removed. This node's next node will point to this node's previous node, because after removal, this node will not exist. So that's the simple remove operation. So let's try insert a node. So in order to insert a node, so basically we need to get the self.end here. So basically self.end. So that's kind of denote this self.end.previous. This one points to the most recent node right now. So this node currently points to the most recent node. So now we need to insert a node. After the insertion, this node will become the most recent node. So in that case, we need to point this one to this node. So make sure, so end of the cache point to newly inserted node. So before that, we need to also update we need to get the previous most recent node. So previous node equals self.end dot previous. So we first need to get this one. And then after that, we need to make sure this next node, previous dot next, this one equals the node. So before you insert this node, previous dot next points to the end, self.end, and now this one is no longer the most recently used element. So we need to make sure this point to the node we inserted. And then after, we need to make sure this node.previous equals this prev. And then after that, we need to make sure the end this end pointer, this end node points to the newly inserted nodes, which is now become the most recently used element. So that's kind of our remove and the insert function we coded. So now let's try to code the put operation. So remember, for this put function, so now you probably know why I'm trying to write all those points down, even though it's pretty intuitive. Let's say you can just read the problem statement and get the idea. But in writing them down and then keep reference to them while I'm writing the code actually saved me a lot of time. That's kind of fun tips from my past experience. Because for this one, I feel this one is a very complicated problem. So, and then it actually took a long time to solve this one and finish code this up. So sometimes, especially when you are kind of like a little bit nervous and a little bit stressed during the coding interview, you may forget your previous thoughts. So I find it's always helpful to actually write down the key idea I had and then also clearly list out the steps how to solve them. And then for this complicated design problem, I also list out the data structure uh, I need to use. So even though I might forget that later while I'm writing the code, sometimes I do because I'm nervous, but I can always keep refer back to my previous node. And then also, this is a very good process. So after writing down the key idea, you can validate this entire process, this idea with your interviewer. So that's one tip for a coding interview. So for the put operation, we also need to check if the key exists or not. So if key exists, we need to update the value of the key. If not exists, we need to insert the value of the key. And we also need to check if exists the capacity or not. So first we need to check if key in self.cache. So in that case, we need to update. So how to update? So basically, it's equivalent to self.remove this node. So we first need to get this node. So node.self cache key. So we need to fetch the corresponding node for this key. And then after fetch, we need to remove this node from the original position. And then we need to insert a new node. So basically, insert. So for insert, it's self.insert. We need to create a new node with the key and the updated value. So that's what we need to do when we need to update the value for key. So else, if key is not in the cache, so in that case, we just need to self.insert. And then I just realized that actually to reduce some redundancy, I need to insert it anyway for both if and else condition. I can just do this like this. So we first check if this key already exists in this cache before. If it exists, we just remove that from the original position. And then after that, whether this key exists before or not, we need to insert the key and the updated value, this corresponding value, into the latest position. So this needs to happen regardless of this key exists or not. So that's kind of how I can actually reduce the redundancy. And then after insert, we need to check capacity. If length if the length of this self.cache, if this after insertion, if this exceeds the capacity, In that case, we need to remove the LRU. So to remove that, remember we have a start pointer, self.start, that next. So that's the LRU. So we just need to call self.remove, self.start.next. Okay, so it seems like we finished coding, but there are like several things we missed while I code this one. So basically one thing is, okay, as I insert elements, I did not update the start. So I didn't have this self.start pointing to anything. So in this case, we are trying to put the element. So let's say, what if my cache is empty? What I mean here is I need to make sure my self.start that's pointed to the list recently used. And then when I'm coding this part, I realized I did not have it pointed to the list recently used anywhere in my previous code. So now I need to do that. So let me see. So basically this start and end, they should tied with the remove and the insert as well. Let's say when you are trying to insert something, if during this insert, if this cache is empty, so you are inserting the first element into this cache. So in that case, you need to make sure self.start. Okay. At the beginning, I think a better way to do that is at the beginning, I need to make sure, okay, when there is no other elements, when this cache is empty, I need to make sure that my start dot next equals myself dot and the previous, and myself dot and so yeah, so basically my self start the next is my end node, and my self and the previous is my start node. So this is what missing. So basically when I first previously I just created start and end, but I did not uh, establish the order. So those two are not connected. So if I did not connect or point to each other for the start and end of this cache, later it will be a little bit hard to actually try to insert and then trying to remove, because for every remove and the insert, even for insert, you need to get the previous, and then for insert you need to get the most recent use as element. That's the previous node of the self.end. So in that case, if let's say during initialization, my self.end previous is my self.start, the empty node to denote the start of the cache. So in that case, during insert, this previous will just be self.start. And in this case, if I insert the first node into this cache, I just point self start. The next will be this node. And then this node's previous will just be self dot start. So that would work when this cache is empty and I'm inserting the first node. It's kind of like an edge case. So now I think this self.start.next is taken care of because it's taken care of here in this general case. When I insert the very first element into this cache, self.add.previous, this previous node will just be self.start because of those two lines during the initialization of this cache. I make sure the start node and end node, they point to each other. So now I should have this code complete. Let me double check to see if I missed anything. So I do the remove. So the remove will work as well. And then I also do the insert. And then for get, I just check if my key already in my cache. If it is, I just get the node and remove the node and insert into the most recent position. And then return the value. I can just return node.value. And then I just put. For put, I need to check if this key already in the cache. I just need to update the value for the key. By getting the node, remove the node. And then in both cases, I need to insert the new node key value. And then check if it exceeds the capacity. If it exceeds the capacity, I just remove the list recently used. So let me try run the code. Okay, I got the wrong answer here. If key in self.cache, I update this node. Oh, one thing I forgot. When I try to remove, I also need to delete the cache. And then when I try to insert, I need to update the self. I need to update, so self cache node the key equals node. Okay, for remove, okay, I made a typo here. So let me try this one, run this one again. Now I get the correct answer. So the changes I made was, okay, previously in the remove and the insert operation, I forgot to update this cache dictionary. So in the remove, after I successfully remove this node, I need to remove this key value pair from the cache, this dictionary. And then after insert, I need to assign the recently inserted node to this cache. So basically add this node.key as a key and then this node as value to this cache. So those two operations or something I forgot previously. So after I add this, it passed the single test case. Now let me try to submit it. Okay, I made another mistake. For this test case, the non-type object has no attribute previous. So for this one, my cache has capacity 1, and I put the corresponding. When I'm trying to put, I need to check if this key in the cache. So I'm calling the remove, and then this remove is defined in the line 66, and then this remove is called from the get function. Okay, it's called from line 83. So basically in this get operation, I'm trying to get the value for key equals 2. So in that case, I check if this 2 already in the cache. So it is in the cache. So I fetch the node. So this node equals self.cache.key. Okay, now I know the mistake I made. So when I insert a node into it, so I need to make sure the node's previous and next point to the correct position. So it's a little bit convoluted here. So when I insert node, I need to get the most recently used element before insert this node. So that is the self_and.previous. So that's this node. And then I need to make sure this previous node currently this points to the this newly inserted node. So make sure this previous node's next node is just the newly inserted node. And then I need to make sure this node's previous node is this previous. So I take care of this. So I point the end of the cache to the newly inserted node. But what I forgot here is node.next equals self.end. So that's the thing I need to take care of. So this line is what I forgot previously. So I only make sure that this node's previous node is the most recently used node by this line. But if I try to have the end of the cache point to newly inserted node, I did not have the newly inserted node point to this end of the cache. So that's this line I missed. So that's why it return error here. So let me try resubmit it. Okay, now we have a working solution. So this problem is pretty complicated as we spend a lot of time trying to figure out how to solve it and actually solve it. I think the most difficult part for this problem is trying to figure out the correct data structure to use. It's pretty intuitive to come up with a dictionary, but it's not very easy to figure out the node in the double linked list. But after comparing it with some other possible ways of solving it, I feel this one is actually the best and cleanest way to solve it. And then you can see during the coding process, I made some small mistakes when I'm trying to perform remove and then insert. So I would say this problem is pretty complicated and as there are a pretty complex problem as there are different aspects we need to take account. So if you like my video, please feel free to subscribe to my YouTube channel. Thank you.